moving away from the proposition logic. There are limitations of proposition logic. It's adequate for to handling statements that where we want to quantify things. Okay, if there is a statement that we want to say about, for example, everyone in this class or someone in this class, the propositional logic is not adequate. What I would have to do is I would list people, or हर बंदे के लिए I will have to make a different statement. Okay. So that's the kind of one problem with the propositional logic. The statement must be repeated. For example, if Alice is a CS graduate, then she knows logic. If Bob is a CS graduate, then he knows logic. If Charlie is a CS graduate, then he knows logic. Okay? There's no way to say all these statements in just one statement. Okay? Condition on the fact कि कुछ आपकी domain के अंदर कुछ लोग CS graduate हो सकते हैं और कुछ लोग CS graduate नहीं हो सकते हैं. Okay? So we escape from the limitations of propositional logic and we go to something called predicate logic. Okay? So predicate logic we have explicit models for objects and their properties, and it allows us to have statements where we have variables and quantifiers. Okay? Variables हमने पहले भी रखे थे, but more important part is quantifier. We will be able to quantify the variables. Okay? For example, we can have constants. Is leap year x is a variable, so is leap year is saying that x is a leap year. Painted Leonardo Mona Lisa. Leonardo painted Mona Lisa. Okay? So that's the predicate logic. Okay, consider that the following predicate logic statement. P of x where x is a prime number. Okay? Is this thing a proposition? Do I ask this question? Let me come back. Okay? So in the next statement we have a statement which says that P of x, just P of x, but what it means is that x is a prime number. Is this a proposition?
Yes.
Should we do a vote? Let's do a vote. People who say yes. Aye. Alright, so is it true or false?
It could only be true or false if you put a value. That makes it false, I guess. That doesn't make it a problem.
Yeah. No one can tell you the truth value of P of x. Right? Because x is an unknown thing. Which means that P of x is not a proposition. Okay? It's not a proposition. For a proposition, you must have a truth or false value. You may not know it, but you must have a truth or false value for it. Okay? There is no truth or false value for P of x until someone tells you x. Okay? Cool. So P of x is actually not a proposition. Okay? It's called a propositional function. It's a function. Okay? So, but these things, यहाँ पे जब मैंने x specify कर दिया, these things are propositions now. Okay? Now we have propositions. All these 6 things are propositions. They may be true or false, but all of them are propositions. Okay? क्योंकि अब मैंने variable को किसी constant के साथ replace कर दिया. P of 2 is of course true. P of 6 is false. P of 4 is false. Everything else is true, right? But all of these 6 things are propositions. P of x is not a proposition. Okay, keep that in mind. Let's not make that mistake ever again. Okay, are we good? Let's move on. Cool. Let's represent the statement students missed breakfast. Okay, we can use a predicate m of x to denote that x missed breakfast and x represents the student. Okay, whenever you write a predicate or a proposition of formula for each variable, I want you to specify the domain of that variable. Okay, किस domain से वो variable अपनी values ले रहा है. यहाँ पे x की domain is the students in this class. Okay, students in this class is the set जिसमें से x values ले रहा है. Okay, m of x is my predicate or propositional formula. For how many of you this is true? Okay, awesome. These are healthy guys. Okay, हमारी मेरे ख्याल में क्लास सुबह 9 बजे होती थी, इसलिए लोग मिस करके आते थे. Last time I asked this question, almost everyone had their hand raised. But today I like 5 people and 4 people. Anyhow, okay, good. Breakfasts are good. Don't miss it. Cool. So this is a predicate formula. X is a variable representing a student. M of x is a predicate indicating that x missed breakfast. This way we can express the statement student missed a breakfast in a predicate logic. Okay. Okay. Here's another one. So predicate q x y z denotes the statement that x square plus y square is equal to z square. अब यहाँ पे एक गलती की है मैंने स्लाइड पे. What's the mistake that I made here? What's the mistake on this slide? I'm saying that qxyz is a predicate, okay, or a propositional formula. What's the mistake that I made here? Girls only. Girls only. What's the mistake here?
Domain is missing.
Domain is missing. Domain of x, y, z is missing. I did not specify कि x कहाँ से आ रहा है, y कहाँ से आ रहा है, or the integers, positive integers, non-negative integers, real numbers, rationals. वो specify नहीं हुआ हुआ यहाँ पे. Okay? Good point. Okay, x, y, z. Okay, for now let's assume that their domain is integers. Okay? What's the truth value of q 3, 4, 5? Q of 3, 4, 5 is true. What's the truth value of q 2, 2, 3? Q 2, 2, 3 is false, right? Because 2 square plus 2 square is not 3 square. How many values of x, y, z make the predicate true? Yeah. How many values? How many values of, assume x, y, z की जो domain है, that's integers, okay? For how many values this is true? Infinite. Infinite. There are infinitely many values of x, y, z for which this is true. And these are known as the Pythagoras triples, okay? For all values of x, y, z for which you can make a triangle, right triangle, this you would get, for those x, y, z, you would get this formula to be true. Okay, you can make you have a triangle, you stretch it, you get another triangle, you stretch it a little bit more, you'll get another triangle. So you can get infinitely many such triangles, which means you can get infinitely many such triples. Okay, cool. This is kind of a so the point I'm trying to make here is that when you say that there are infinitely many triples for which this thing is true, you need to be able to come up with an argument which convinces someone why this is true. Either you iterate everything in the integers, okay? या फिर आपको you will have to give a logical proof of it. I gave you a logical proof of it why this is true. What I told you is that if you take a right triangle, for that right triangle you have 3 values for which this is true. Now I can stretch that triangle a bit more and I'll get new triple. And I'll keep doing it and I can do it infinitely many times, which means that I can get infinitely many triples for which this is true. Okay? Make sense? There are going to be statements which are absolutely obviously true, but you're going to have to give me a reason why they are true. Until you give me that reason, your answer won't be accepted in this class. Okay? All right. So how many right triangles are there? There are infinitely many right triangles, so there are infinitely many triples there.